So friends, today we are going to discuss a new numerical problem which is based on the simply supported beam. These are the three moments acting at the point B, C, D respectively, and we have to draw the shear force diagram and the bending moment diagram. So the first step is always to find out the reactions at these supports. That is the reaction at the point E we have to find out, suppose it is acting in vertically upward direction, and the reaction at the point A we have to find out, suppose it is acting in vertically upward direction. Now using first equation, that reaction at A plus reaction at E is equal to the net vertical load acting over this beam. So the net vertical load acting over this beam is 0. So that's why RA plus RE is equal to 0. So this is our first equation. And the next equation is obtained by sigma MA is equal to 0. That is summation of movement about point A because of all these influences is equal to 0. So because of this RE, there will be a movement about point A of magnitude RE into this distance. This distance is actually L. Total distance is L here. Okay, so this distance is L. So because of that, the moment about the point A will be equal to RE into L, this distance, and it will act in anti-clockwise direction. Why? Because this reaction RE is trying to rotate this beam AE in anti-clockwise direction about this point A. Okay, now because of this movement of concentrated movement 4m, there will be a movement about point A going in clockwise direction. So we will take minus 4m here. Okay, why it is taken minus 4m? See here, if this is the point A, suppose, okay, and this is our beam, the point D is lying here exactly below this point, and this movement is acting in clockwise direction like this. Okay, so it is trying to rotate this beam element AD in clockwise direction. That's why it is taken as clockwise, and clockwise we treat here as negative. Now this movement is trying to rotate this beam element AC in anti-clockwise direction about the point A. So we will take here plus 6m as anti-clockwise, and because of this movement, this is going in clockwise direction like this, and it will act as negative movement of 2m in clockwise direction. So when we put all these things equal to 0, then what will we get? We will get reaction at E is equal to 0. So using this equation, that is the first equation, by putting the value of RE here, we will get RA is equal to 0 also. Now friends, we will calculate the shear force at the point A, B, C, D and E. We will calculate the shear force on the left side of this point A, denoted by this term, and on the right side of the point A, denoted by this term, because there is a reaction RA acting at this point. So shear force will change suddenly when going from left side of the point A to the right side of the point A. Same is true for the point E, because a reaction RE is acting at this point E. And because at point B, C and D there is no vertical load acting, that's why we have to directly calculate the shear force at the point B, C and D, denoted by these terms. Now friends, we will calculate the shear force on the left side of the point A. So for that, what we have to do? We have to construct a section here on the left side of the point A. See this section, XX. Now looking on the left side of this section, there is no force lying on the left side of this section. That's why shear force at this section is 0. So taking shear force here as 0. Now shear force on the right side of the point A we want to calculate. For that we have to rub this previous section and construct a section here on the right side of the point A. So this is a section on the right side of the point A constructed. Now looking on the left side of this section, this force RA acting here at this point A like this is contributing toward a shear force about this section XX, which is positive in nature, and it will give us RA is equal to it will give us shear force at the right side of the point A about the section XX is equal to RA, and RA is equal to 0. Okay. Now shear force at the point B we will calculate now. So draw a section passing through this point B, and looking on the left side of this section you can see that this force is contributing toward the shear force, but this force is 0. That's why shear force at this section XX, which is passing through the point B, is 0. Similar is true for the point C. You can do that also in the similar fashion that I have done earlier for previous 3 cases by constructing section, and shear force at D will also be equal to 0, and shear force at E will also be equal to 0 on the left side and on the right side. You can do it by yourself, okay, in the similar fashion that I have done for these 3 points. Now friends, we will draw the shear force diagram. For that we have to draw this line AE. Okay, this is the line AE here. Now this is the point B, this is the point C, and this is the point D. Because shear force is 0 at every point, so the shear force diagram will be this line. Okay, because shear force is 0 at all the points A, B, C, D, and E. So shear force diagram will be this line. Now we will draw the bending moment diagram. Now friends, we will calculate the bending moments at these points A, B, C, D, and E. For that we have to calculate the bending moment at the point A and bending moment at the point E directly by constructing a section at the point A and point E, and we have to calculate the bending moment on the left side of the point B and on the right side of the point B. Why? Because there is a concentrated moment acting at this point B, and it's due to which the bending moment will change suddenly when going from left side of the point B to the right side of the point B. Similar is true for the point C and D also. That's why we have to calculate bending moment on the left side of the point C and on the right side of the point C, and on the left side of the point D and on the right side of the point D. So we will calculate now. Now first thing is we have to calculate the bending moment at the point A. For that we have to construct a section passing through this point A. Suppose this is a section which is passing through the point A. This is the section XX. Now looking on the left side of this section, there is no force line, no concentrated movement line on the left side of this section. So the bending moment at the point A is 0. Now we will find out the bending moment on the left side of the point B. So constructing a section on the left side of the point B. This is the section constructed on the left side of the point B. Now looking on the left side of this section, you can see that this force is contributing towards the bending moment about this section XX, but the magnitude of this force is 0. Okay, RE is 0, RE is also 0. That's why bending moment is 0 here also. Okay, on the left side of the point B. Now on the right side of the point B, when we want to calculate the bending moment, then we have to construct here a section on the right side of the point B. So this is a section constructed here on the right side of the point B. Now looking on the left side of this section, this force is contributing 0 bending moment about this section XX because its magnitude is 0, and this concentrated movement is creating a bending moment of 2m about this section XX, and it will have a positive sign using this sign convention. Why? Because if a bending moment, if a concentrated movement is acting on the left hand side of a section XX and it is creating a clockwise rotation, then we assume it as positive. Similar is the case here. This movement is acting on the left side of this section XX and going in clockwise direction, so treat it as positive. Now friends, we will calculate the bending moment at the point C. For that, what we have to do, we have to construct a section on the left we have to calculate the bending moment on the left side of the point C. So for that, what we have to do, we have to again construct a section on the left side of the point C, and looking on the left side of this section, only this moment is contributing toward the bending moment about this section XX. So the magnitude of this moment will be again plus 2m using this sign convention. And bending moment about the point on the right side of the point C, when we want to calculate this, we have to construct a section on the right side of the point C. This is the section XX. Then this movement, these two movement, concentrated movement, are accounting for bending moment about this section XX only. This force is not accounting for anything because its magnitude is 0. So because of this movement, there will be a moment of plus 2m here, and because of this concentrated movement, there will be a moment of minus 6m using this sign convention because it is going in anti-clockwise direction and lying on the left hand side of this section XX. So using this sign convention, it is coming out to be negative, and it will come out to be minus 4m. Now bending moment on the left side of the point D we will calculate by constructing a section here on the left side of the point D. When we calculate, because of this concentrated movement, there will be a movement of plus 2m, and because of this concentrated movement there will be a movement of minus 6m, bending moment of minus 6m, and it will again give us minus 4m. Now bending moment on the right side of the point D, if you want to calculate, then we have to construct a section here on the right side of the point D. Now looking on the left side of this section, you can see that this movement is contributing toward plus 2m using this sign convention. This is contributing toward minus 6m using this sign convention, and this is contributing toward plus 4m using this sign convention, and all of these will give us how much? 0 bending moment. Now friends, bending moment at the point E, if we want to calculate, then you can see that bending moment, when you calculate, the same calculation will repeat as in the case of right side of the bending moment at the point D, and it will give us plus 2m minus 6m plus 4m is equal to 0. Okay, so we will now draw the bending moment diagram. For that, we have to draw a line here up to a same scale as this AE. So this is the point A, this is the point B lying exactly below this point B, this is the point C lying here, this is the point D lying here, and this is the E lying exactly below the point E. Now bending moment at the point A is 0, so I'm working across here. Bending moment on the left side of the point B is 0, and it is increasing to plus 2m on the right side of the point B. So plus 2m will lie somewhere here, and it is going to plus 2m on the left side of the point C, so will lie in the same level, and it is coming out to be minus 4m on the right side of the point C, so minus 4m will lie somewhere here, and it is going to minus 4m on the left side of the point D, and going to 0 on the right side of the point D, and again at the point E it is 0. So joining first point with the second, first point is joined with the second, second with the third, third with the fourth, fourth with the fifth, fifth with the sixth, sixth with the seventh, and seventh with the eighth. We will get our bending moment diagram. Now friends, the line joining the point B and C is a straight line, and line joining with the point C and D is a straight line because there is no concentrated movement, no vertical load lying between the point BC and CD. So this was all for today's topic, friend. If you like my video, you can subscribe my channel and also press the bell icon for the notification of the upcoming videos.